Okay, so today in class we looked at how to find the distance between 2 points on a coordinate plane using the Pythagorean theorem. So let's say we wanted to plot the points 2, 2 and negative 1, 4. So 2, 2, remember these are x, they're written x comma y, so your first coordinate is going to be left to right and your second coordinate is going to be up and down, x-axis, y-axis. So to plot the point 2, 2, we would go right 2 units and up 2 units. And to plot the point negative 1, 4, we would go back 1 unit and up 1, 2, 3, 4. So we're trying to find the distance between these 2 points right here. And one of the things that we discussed in class is that it's a diagonal line. If it were a horizontal line or a vertical line, we could just count the number of blocks and see how long it is. But because it's a diagonal line, we can't do that. So one of the strategies that we can fall back on is to understand that this diagonal line segment, we can basically turn it into the hypotenuse of a right triangle. So there's 2 different right triangles that you can make. You can make one below the line segment and one above the line segment. It doesn't matter which one you pick, you're going to get the same answer either way. So I'm going to make my right triangle below the line segment. So now we just have to figure out how long those 2 sides are. So if I count from here to here, I'm going 1, 2, 3 spaces. So this is 3 units long. And I can confirm that by looking at these. If I start at positive 2 and run all the way back to negative 1, that would be a difference or a distance of 3. Okay, if I start here and go up, I go up 1, 2. And again, I can confirm that because from 2 to 4 is 2 spaces. So now I have a right triangle with legs measuring 2 and 3. So I can just use the Pythagorean theorem and find C, and that would be the length of my line segment. So a squared plus b squared equals c squared. I know that my a and my b are 2 and 3. 2 squared plus 3 squared equals c squared. I know that 2 times 2 is 4, and 3 times 3 is 9. So 13 is equal to c squared, but I don't want the square. I don't want the area of the square. I want the actual distance. So I need to do the square root of 13, which I'm going to approximate. I don't have my calculator with me because I'm using my phone and I can't stop the recording to check it. So I know 3 times 3 is 9, and that's not enough. And 4 times 4 is 16. That's too much. So somewhere between 3 and 4, 13's a little bit closer to 16, so I'm going to go with maybe, let me change that to a squiggle, maybe 3.7. So the approximate distance of this line segment is 3.7 units long. We can use this with any points that we can plot on a coordinate plane. Right now we're plotting it and drawing the triangle, but eventually we want to get to, my cat is walking on the table. We want to get to the point where we can just look at our ordered pairs and say, okay, there is a distance of 3 and there's a distance of 2, and apply the formula just from looking at these 2 numbers.